how easy it is to set up an empirical calibration with our X-Supreme. So just go to the software, other functions, method setup, and say new method, new calibration method, and click on the button create calibration method. Then a new window will open and the software guides you automatically step by step through this calibration procedure. First thing is to enter a method name. In our case, we want to calibrate silicon on paper samples. So the method name should be silicon on paper. Then say next. Now we want to select which analyte needs to be measured. So of course it's silica. In the next step, you can give your predefined name, so you can choose if you want to see in the results later on only the element symbol, so the SI, or you want to see the complete element name, then it would be silicon. Or you can choose for any other methods if it should be a compound or a user-defined name. I want to choose only the symbol. Now we can define if we want to see the results in percentage or any other unit. So for our case, we want to see gram per square meter. And you can choose how many decimals you want to see. Next. Now you have the possibility to choose an overlap. So for example, when you have two elements which are near to each other, let's say manganese and iron, then it could be that the beta peak from manganese overlays the alpha peak from iron. We don't have any overlays here, so we can click next. Here we can design a condition with which the sample should be measured. In our case, we want to choose silicon on paper condition. We can choose which ROI should be assigned, so which region of interest. We just choose the region of interest for the K alpha peak for the silicon. Here we can set the current and the measurement time. So measurement time, 30 seconds enough, and current, we use 600 microamps. So it's important to know that your tube maximum can have 3 watt. So when you use 5 kV, the maximum current should be 600 microamps. And we would want to use the spinner option. So this helps when you have not so homogeneous samples to get a good overview over the complete surface of your sample. Next, here you can see the order of your elements. That means when you not only have one element in your results, but you want to see the results for several elements, you can set the order by atomic number or by a user-defined order. And in the last step, you can choose if you want to save the results from your method automatically in a predefined folder and in which format it should be stored. Here you can choose if you want to do repeat measurements or only a single measurement, so only one measurement for your routine measurements. Now you can click on Save and you see that the method has been saved and you are able to measure the standards with the known concentrations. We are now preparing an empirical calibration. Empirical calibration means that you need standards with known concentration to create a calibration curve. In this calibration curve, the known values for each element of your standards will be plotted against the intensity for this element. This is why we now measure our standards. Go to Measure Standards and click on the button. You will get the information message that no calibration standards assigned until now. And yes, we want to add new standards. So for this, we can enter a name for the first standard. Let's say standard A. Next. Oh, it's existing, no problem. Then we say A silica. And next. Now you can enter the concentration for standard A. It's 0.629. Next, here you could define some qualities of your standards, but you don't have to. Then you can click on Finished and you can add another standard. I will do this for the next standards. Once all standards have been assigned, a next window will open and you see your standards all here, and you can check if the concentrations or the layer thickness which you have put in is the correct one to this one on your certificate. Then we can go to the next step and assign each standard to one position on your sample tray. So let's say L1, H1, E, A, and the blank one. Now we can open our lid and put the samples in. Here you can see a silicon on paper holder. I will disassemble it. Then I will take one of my standards, and you see we do have a shiny side here. This shiny side needs to be upwards. Then we assemble the holder again. You can see like this, and we put it in the sample tray. I will put also the other ones in the sample tray. In the same order we have adjusted them in the software. I will close the lid. Click on Continue. And you will see the screen similar to the routine measurement screen, and you can press on Start. When the measurement starts, you see the total time for all measurements remaining here. And when a measurement for one sample has started or is going on, you can see it in the yellow color. All the samples which are waiting to be measured are in red color. As soon as a measurement for one sample has finished, this sample will be shown in green color. As soon as the measurements for the standards has finished, you can see in the new window the standards or the concentration you have put in for the standards, and you see the intensity, which are in the region of the interest for the K alpha line for the silica. We can click Accept All. Yes, we want to use this, and we have to go to the regression step. Now we can go to Other Functions and open the regression. In the regression window, you can see the known values for your thicknesses for the silicon on the paper against the calculation values. When you go to the Graphics tab, you see the calibration curve, and you see it is here a really nice straight line. So no corrections needed for this calibration. Back in the regression data, it's important to know that you can find here the information for the standard error. This standard error indicates the accuracy for your measurements. So the smaller the standard error is, so more accurate your results are. Now we can close this window and say, yes, we want to save this regression. And then your method is ready to use in the routine measurement. So go back, and you are ready for measurements.